Okay, here's the section 3.4. I'm trying to get this thing to skip right now. Of course, it's going to wait until I'm in the middle of something. So this subcomp problems that I'm going to do here at the open, these can be a little bit challenging sometimes. Remember, angles that are supplementary, angle pairs that are supplementary add to 180 degrees. Angle pairs that are complementary add to 90 degrees. Okay. What I'm going to do is I'm going to translate these word problems directly into an equation. Okay. Now, one thing I want to remind you of is we're always going to call the angle x. So the measure of an angle, we're always going to call that x. The measure of an angle, so now I'm going to begin my equation. X is, we know is means equals. Now, this is where you got to be careful. 30 less than, it's supplement. Well, 30 less than means subtracting 30 from something. So it's not 30 minus, it's something minus 30. And we're subtracting from its supplement. Well, if we call the angle x, the supplement has to be 180 minus x, right? Because supplementary angles add up to 180 degrees. So and then we subtract 30. So there we go. The measure of an angle, boom, is, boom, 30 less than its supplement. So setting it up, that's the hard part. The solving, of course, is easy. Now, what you got to be careful for in the very end is just make sure you answer the question. It says find its measure. It's referring to the angle, and we call the angle x. So we're actually all done right here. X equals 75. Now, the next one, the measure of the supplement of an angle. So the supplement of an angle would have to be 180 minus x, because remember, we're always calling x the angle. Is 60 less than, so that means equals, we have to subtract 60 from something, right? From what? 3 times the measure of its complement. Well, if the angle is x, the complement's 90 minus x, and then we subtract the 60. So we do a little distribution. And folks, I'm sorry about this mistake. I don't know why I wrote this 3. That 30, that was supposed to be just a 3. Fix that. So I like to move the x's to the side where they're positive, so I'm going to move them to the left. I get 2x over there, and I will end up getting 30 on the right, so x equals 15. Now you got to be careful. If this was a multiple choice test, one of the answers would be 15, one of the answer choices. But the question said find the measure, to find the measure of the angle. We did find the angle, 15, we're actually done. It's the next one, you have to be a little bit more careful. If 3 times the measure of a supplement, so 3 times the measure, if 3 times the supplement angle is subtracted from 7 times the measure of the complement, so 7 times the complement, what are we subtracting? We're subtracting 3 times the measure of the supplement. The answer equals is the same as that obtained by trisecting a right angle. Well, that's, of course, 30 degrees. So we just have to do basic algebra. Be careful here. Negative times a negative is plus 3x. So we end up getting negative 4x. And 630 minus 540 would be 90. If I subtract 90, I get negative 60. We end up getting x equals 15. But yeah, here the problem is saying find the supplement. So our supplement, of course, would be 165. Okay. All right. Okay, so we're going to do more now with the sup and comp stuff, but we're going to talk about it more in the context of proofs, and I'm hoping that this is going to all make sense for you guys. Have your reason sheet handy as well. So take a look at this. This is just kind of to help with your understanding. If this is a right angle, and then this is a right angle as well, okay, that means they both measure 90, of course. Well, that means that it goes on and tells us that ORL is 60, so that means 30 and 30. So, you know, these little outer angles ended up being both 30, they end up being congruent. Well, remember, these two angles out here were both complementary to the same angle. So that's a new theorem, and this is going to be gold number 17. If angles are complementary to the same angle, then they are congruent. Now, the same thing also holds for sup. If angles are supplementary to the same angle, then they are congruent. Okay, this is gold 17A. Now watch this. To measure, I usually don't show comps or sups. I don't indicate them with tick marks, but if I have to here, F is comp to G, so I'll put a, you know what, this is just going to get too messy. Let's say G is congruent to J. So let's think about this here. F is comp to G, H is comp to J. Well, these two angles are congruent, so I hope it logically follows that these two would have to be congruent, because if angles are comp to congruent angles, it's very similar to this over here, right? Then they are congruent. If angles are comp to congruent angles, then they are congruent. This also works with supplementary. This is gold number 17B. Remember, the gold sheet, folks, that's the reason sheet. I always print it off on gold paper, so that's why I always refer to it as the gold sheet. So this is number 17, okay? Makes sense, I hope. Now, let's go ahead and do a proof down here. There is, let's see, we got perpendicularity. We got ABP. I'm just marking my diagram. I like to mark my diagram right away. And then remember, I'm not going to, just to save time, I'm not going to write out step 1. You know, that would be the given stuff. But now I got to catch up to my tick marks, okay? So, you know, I mark perpendicularity down here. Usually when we do that, we need to say that angles ABD, comma, angle DBC are right angles. And this is our gold sheet. No, this is number 10 on the gold sheet. If lines perpendicular then intersect at right angles. Again, I think that makes sense. You just got to get comfortable with the wording. And now you're probably, you know, we have to prove that this angle here, this unmarked angle, is congruent to that. And most of you guys are probably saying, oh, well, that's really going to be easy because these two are complementary, these two are complementary. So that means these two have to be congruent because they're complementary to congruent angles, kind of what we just talked about, right? But we have to be careful. We first have to say that these angles here are complementary, these two and these two. We can do it in the same step. Angle ABP is comp to angle PBD, comma. Angle DBW is comp to angle WBC. Now, why are those angles complementary? Because together they form this right angle. And this is something on our gold sheet as well. This is gold number 15. If 15B actually, if the sum of two angles is a right angle, then angles are complementary. I know it seems silly, but yeah, we still have to say that they're complementary. And so now, look, these are the two angles that we need to show congruent. We've mentioned both of those angles here. We've said that they're each comp to I just realized I forgot to do, oh no. We've said that they're each comp to these two angles, and we've said that those two angles are congruent. So now these two angles must be congruent because they're comp to congruent angles. So we can conclude here. Angle PBD is congruent to angle WBC if angles comp to congruent angles, then congruent. And again, that's gold number 17B for reference. Not too bad, I hope. So there's a couple proofs on the back. Let's see here. You can probably guess. Let me start marking this up. AB perpendicular to B, disappearing ink. Let's see if we can get it to stick. FE and BE. ABC congruent to FEG. And I'm hoping you can kind of... Oh, now look, it also says that AF bisects BE. So that means this is going to be congruent to that. All right, we got a lot to do here. Now, BCD, we have to prove that BCD is congruent to what triangle? Well, that's going to be over here. Make sure you match it up correctly. BEGD. Again, I'm going to start with step 2 just to save time. But I got to catch up to my tick marks. I put a lot of stuff on there. And first thing I'm going to state is that I have right angles. Very easy to forget some of this. This should say angle ABD, comma, angle FED are right angles. And this again is if lines perpendicular then intersect at right angles. Okay. Now you're probably thinking, hey, I got these congruent. I know this is comp to this. I know this is comp to that. So then I can get these angles congruent. But we first have to say that they're complementary. Angle ABC is comp to angle CBD, comma, angle FEG is comp to angle GED, and that's what? If the sum of two angles right angle, then complementary. Okay, we're getting there. Now we can say that those little angles there, angle CBD, is congruent to angle GED if angles comp to congruent angles, then congruent. Okay, getting there. So now look at these two triangles that we're going to show. We got this pair of angles and these pair of angles congruent. Now I have these tick marks, but I still haven't said that, so I got to be careful. BD congruent to ED. I probably should have said that right in the beginning, but it's okay. And this is from your reason sheet. This is like number 5, right? If segment bisects a segment, then it divides it into two congruent segments. Okay, now we're almost there. So we got the pair of angles here and here. We got a pair of sides. Remember, our other angles are going to come right here. These are those vertical angles, right? Angle CDB is congruent to angle GDE. This is one that you don't have to say if then. Vertical angles are congruent. And then we can finish down here. Triangle BCD is congruent to triangle EGD. And we did that by ASA. Okay. Got one more proof on this sheet. Again, I'm going to start with step 2. I'm going to mark up my diagram, WOC, IJL. Now this one's hard to show, so CJ and OI, I'm just going to make a mental note of that. WO and LJ. Okay, now we have to show that these left and right triangles here are congruent. We already have a pair of sides. Actually, we have another pair of sides too, because remember they gave us OI and CJ. So we have two pairs of sides from the given. So all we need is to get these angles here, and we're all set. Now remember, these two angles here, remember we're allowed to assume a straight line and a straight angle. So these two angles here must be supplementary because they add up to that straight angle. So we can start there. Angle COW is supplementary to angle WOJ. And in the same step, we're going to do these two angles here. Angle IJL is supplementary to angle LJC. And this is if the sum of two angles is a straight angle, then sup. So that's pretty awesome. If these are sup and these are sup, these are congruent. That means these inner ones, angle WOJ, must be congruent to angle LJO. I said LJC up here, but it's the same angle. And this is what? If angles sup to congruent angles, then congruent. That's the new thing from today. And then we're all set. We can say triangle OWI. This is just 4 steps. Supplementary to I. Whoops. I didn't match that up correctly, did I? Actually, I is not even in that one. OWI would have to be JLC, which is what it says right here. And that's going to be by SAS. All right.